Okay. So technology uses and analysis, which is kind of run through some software, basically. Perfect use of technology-driven processes to analyze data, making more informed business decisions. So you've probably both all heard of Internet of Things, connecting any device with an on-off switch to the internet to allow performance to be monitored and controlled, and the robots will be able to take over the world. So big data, another thing besides the Internet of Things. Large data sets that include both structured and unstructured data require special processing. So big data comes from all this Internet of Things. Has significant potential to discover hidden patterns, relationships through statistical and forecasting models. Yeah, if you can sift it down to what you need. Current applications for big data, telematics, real-time performance of vehicle fleets through sensor technology, which we use in our industry. Wearable technology, human heart rate, body rate, which you use if you're training for something. They got heart rate monitor straps that talk to watches that talks to the internet. Delivery tracking, we use this down in logistics, find out where the trucks are at. Smart sensors, uh, equipment can send condition updates through smart sensors to a central location. So you got, these are your big data things: variety, forms, veracity, how good is the data, analysis of flow for velocity and volume. And then there's data mining, which is related to big data, searching large and complex amounts of data to find trends. So data may come from proprietary systems or the internet, and data may also be aggregated, cleansed, and stored in the data warehouse. Most data has to be aggregated and cleansed. Some of the pertinent skills required for data mining are understanding methods of qualitative and quantitative forecasting, which we covered in the last test. Awareness of different methods of estimation and sampling, awareness of methods to estimate functions related to independent variables, dependent variables, linear regression, basically the scientific method. And using probability theory to estimate expected outcomes or values, which is basically statistics 101. Then we have, once you've sifted through all this data, now you've got to visualize it. How can you communicate the data to an audience visually so that they can comprehend it? Dashboards are a very common way. Key performance indicators or metrics, much like gauges on an automobile dash. Visually communicate the relevant status of KPIs in a concise format. And provide a forum for defining priorities and addressing issues. So the dashboard. And then you've got criteria for purchasing software programs, for instance, the ERP program. Disaster recovery, scalability, architecture, service requirements, functionality, vendor viability, technology, cost, support, industry expertise, implementation, all good things. Functional criteria includes concerns such as the evaluation of capabilities of a new application. How well does it work for the purchasing department? And then general business. Assess concerns of providers such as, how big is the supplier, what's their customer base, what's their experience, their financial stability, etc. And then we've got the ERP system, which is what our GPPS is, otherwise known as SAP. Enterprise Resource Planning Systems. It's a type of software program that integrates various functions within an organization. So in test 2, we studied, originally they came up with the MRP, Material Requirements Plan, and MRP2, and then the ERP system basically came out of all of that. Power of an ERP system lies in its reliance on central relational database. Only one user must update a single record, and the rest of the users are then able to review the updated information. That's what the central relational database is all about. Other data management systems. So MRP, which is part of a ERP system, automatically disassembles the bill of material and drives material order requirements based on a schedule. And then MRP2 came about in the late 80s, where they added the costed BOM and finance and marketing to the MRP system. And then it gradually turned into an ERP system. EDI, oh, I had fun with this today. Exchange of computer to computer business information in a standard format. You'd think it would be pretty simple, but Toyota and PACCAR seem to be having issues. Usually purchase order, shipment, and invoice information is exchanged. Supplier portals. So on site on the internet that stakeholders navigate to in order to communicate with the organization. So this is our portal, ERP or e-portal system. Usually shares information like forecast, scorecards, training materials, bids. Any place that one can visit on the World Wide Web is a site. More specifically, a website. This is a little bit dated information. Large number of links to other websites is a portal, such as Google, Bing. It's normally used as an entry point. So I don't know if you'll still see this, but they used to have questions on what a horizontal portal is, which is Bing or Google, and the vertical portal, which is a more narrow thing like purchasing.com or spendmatters.com, etc. Sourcing suites, integrated add-ons or software solutions to the ERP system. So, there's a couple of big systems, SAP and Oracle, and their interfaces all stink. They're just hard to use. So you use that as the database engine, and every functional department buys their own software interface that talks to the database. Ours is Ariba that we're moving to. Business intelligence software that provides purchasing information for decision making, can be standalone or part of a sourcing suite. Most of these things, what they're looking at is scanning the world news, spend analysis software, historical spending patterns in an organization used by commodity or category code, how many supplier providers each SKU, other questions like how much spend is supplier having, are all plants getting the same price, and performance management software, applications that store performance data like contract or KPI. This would be our SPM software. Can be tied to scorecards and can include only information visible to supplier management like risk analysis. And then you got contract management software, general repository for all contracts, which we would use to facilitate the automation of key steps in contracting, alert supply management to important dates like contract renewal, and can generate reports on internal or external compliance issues. So that's about what a private industry would use a contract management software for. The government gets a lot more involved with closing contracts and all this good kind of stuff. And then you've got AI, artificial intelligence, cognitive procurement, promises to perform tasks with greater speed and more accuracy. You'd think all these guys working on AI would actually watch a science fiction movie, but hey. Eventually, AI will be able to perform tasks such as market assessment, supply management, material management, demand forecasting, risk management, contract management. It's a ways away, but basically the mundane day-to-day stuff in the purchasing. In order to accomplish these tasks, AI is going to require clean, accurate data. Always a problem in an ERP system. Cloud computing technology, IT resources that are external to the business for purposes of storage and computing. This is where everybody's headed because it's much cheaper. Organization does not have to invest in an IT infrastructure and have its own server farm. They can just rent one. Cloud computing services have the following variations. And you may see questions on this stuff. So infrastructure as a service, IaaS. Think of it as the unfurnished apartment. You're just renting server space. Then you got platform as a service, PaaS, partially furnished apartment. Develop and run and manage applications. The platform is optimized to run our applications. And then you've got software as a service, SaaS. That's the fully furnished apartment, customized features, all the software maintenance and upgrading is done for you. Obviously, that is the most expensive. So IPS, infrastructure as a service, platform as a service, and software as a service. Think infrastructure is cheap and software is expensive. And then we've got blockchain technology, continuously growing list of records called blocks, which are linked and secured using cryptography. So when we say the words block and chain in this context, we're talking about digital information, the block, stored in a public database, the chain. And blocks on the blockchain are made up of digital pieces of information. They have three parts, basically. Store information about transactions like the date, time, and dollar amount. And they store information about who is participating in the transactions. And they store information that distinguishes them from other blocks. Much like you and I have names, each block stores a unique code or what's called a hash that allows us to tell it apart from every other block. And hashes are cryptographic codes created by special algorithms. So a blockchain, as its name suggests, consists of multiple blocks strung together. For a block to be added to the blockchain, however, four things got to happen. Transactions got to occur. The transaction's got to be verified. Network of computers will rush to check your transaction, make sure it happened the way you said it did. They confirm the details, including transactions, time, dollar amount, and participants. And then that transaction must be stored in a block. The dollar amount, digital signature are all stored in a block. And that block has to be given a hash. The block also is given a second hash of the most recent block added to the blockchain. So that way you can't, it's very difficult to duplicate. Once hashed, the block can be added to the blockchain. And when the new block is added to the blockchain, it becomes publicly available for anyone to view. And each computer in the blockchain network has its own copy of the blockchain, which means there are thousands, or in the case of Bitcoin, millions of copies of the same blockchain. Although they still seem to rip off these Bitcoin dealers, so I don't know how they're doing that. But although each copy of the blockchain is identical, spreading that information across a network of computers makes the information more difficult to manipulate. And hash codes are created by a mathematical function that turns digital information into a string of numbers and letters. If that information is edited in any way, the hash code changes as well. In order to change a single block, then, a hacker would need to change every single block on every copy of the blockchain before it could modify the blockchain. But they still seem to steal it, so who knows? All right. Joe is a category manager for Acme Corporation, and he is trying to work with his supply base to ensure that it does not run out of a critical part that is very expensive. In order to accomplish this, he and his suppliers all need to consolidate their different scheduling and inventory systems along with data from smart sensors on his manufacturing floor. What should Joe's next step be? Any answers you can provide?
Yeah, I would go with A. Buy a single ERP system and make all suppliers use it.
That's what I'd do. Let's see if these guys agree. B, what Joe needs to do is combine a number of data sources from various devices into one coherent report. Big data. Okay. I still like A better, but all right. Okay, one more here. Ann Abel is an IT services procurement manager for a medium-sized company. She is trying to determine what types of service she should get for their new ERP system. Company has a small IT staff and they have purchased an off-the-shelf ERP system that will require frequent updates. The company management does not want to invest in any more resources in its IT department currently, but it is essential that the company maintain the new ERP software. So what type of service should Anne recommend they purchase? Small IT staff, and they got an off-the-shelf ERP system that requires frequent updates. Any guesses here? I would say they're not going to purchase their own servers. And then you've got basic, medium, and extensive, the fully furnished apartment. So that's probably what I'd go with, this fully furnished apartment, because they don't want to invest anything and they got a small IT staff and they got an off-the-shelf ERP system with frequent updates. I'd just let somebody else do all that mess. Let's see if they agree. D it is. Software as a service, fully furnished apartment with unique features. All right, there's 7 questions out there. So I want you guys to go ahead and get after them. And just raise your hand when you get done. Otherwise, we'll go over answers at 3:55. Use a block.
Looks like we're all done, Rick.
Oh, not paying attention here. Okay. Number 1 is Charlie. Number 2 is Alpha. Blocks hold the information for the chain. 3 is Delta. Regular dashboard reporting will provide senior management with quick visibility. 4 is Bravo. Complies with all specified criteria. 5 is Alpha. Internet search engine would be the best place to start. 6 is Delta. Electronic tools are optimally used to automate the acquisition of non-critical, standard, routine, and leveraged items. And 7 is also Delta. Tracking future-oriented can only provide information based on multiple results. Only then can tracking comparison be done. All right. So tomorrow, what are we going to work on tomorrow? Another section here. Oops. D2, conducting market research. Talk to you guys then.
Thank you, Rick.
Yep.